Alright, hello 7th grade. So this is the Chapter 9 review, and here's how this is going to work. There is a copy of the review in the description below. There's a link to a Google Doc in there that has all the questions for the review, so that you can open that and follow along with what's going on here. I did write most of it out on the whiteboards, but there are a couple of the story problems where I didn't write out everything, just because that would be kind of long and hard to read off the whiteboards on the screen. So I figured I'd put that in a Google Doc. You can go in and open that up before you start watching the video, and make sure you take some good notes as we're going along. Test is going to be open book, open notes, because I obviously don't have a way to stop you from using either of those things. So go ahead and use your book, use your notes. If you left like half your notes at the school because we got halfway through this chapter before we let out, don't freak out. Just take some good notes while we're going through the review. This shouldn't be that terrible. I didn't make the test that long. We're just hitting kind of the main points of Chapter 9 that I might want to make sure that we get to. So hopefully this isn't going to be that bad. Once you're done with this video, then go ahead and email me and I will send you a link to how to get to the test. So make sure you watch the video first. Don't skip to the end. Alright. So I'm going to assume by now you've paused the video and opened up that Google Doc and you're following along with the thing that says we have a spinner over here and we want to find the probability of spinning a 3. So this is back to the stuff with simple probability that we're talking about at the beginning of the chapter. So we only got one thing going on. We just got this spinner that we're spinning. And again, we're assuming that it's fair and all these are equal size, even if Miss P didn't quite draw them all equal size. We're assuming that those are equal. So assuming those are all equal, we got 1, 2, 3, 4, 5, 6, 7, 8 parts. And 1, 2, 3 of them are 3s. So we get 3/8 is your probability. And if you want to leave that as a fraction, that's fine. If you want to turn it into a decimal, that's fine. If you want to turn it into a percent, that's fine. Personally, I would just leave it. But, I mean, if you want to do either of those two other things, that's fine too. You only need one or the other, so you don't, need all three, fraction, percent, decimal. One of them's fine. Okay, same sort of thing with this next one. We've still got 8 parts on our spinner. And we want to know how many of them are 2 or 3. So we got 1, 2, 3, 4, 5, 6 of them that are either 2 or 3. And I'm not going to dock you for not reducing your fractions, but technically that's 3/4. So, I mean, go ahead and reduce them, but that's not something I'm going to dock you points for, not the main point right now. We're looking for this, or if you call that 75%, or if you call that 0.75, we're good. Okay, now we want the probability of getting something odd. So we've still got 8 parts of that circle, and odd numbers, 1, 3, 5, 7, but really on the spinner we've only got the 1 and 3, so we got 3, 1, 3, 3, 1, so we got 5 of those. That doesn't reduce. And again, I would just leave that as a fraction. If you really, really want to turn it into a decimal, go for it. Top divided by bottom. If you want a percent, go ahead and move that decimal 2 spots. I would just leave it. Okay, and now I want the probability of getting something that's not a 3. So we've still got 8 parts. And we had 1, 2, 3 of them that were 3s. So you can either go and count up the ones that aren't 3 and go, okay, well, 1, 2, 3, 4, 5 things that aren't 3s. Or if you said, well, I had 3 things that were 3s. So if I have 8 things, the other 5 have to be not 3s. Either way, getting to that 5/8 is fine. And again, that one's not going to reduce. I would just leave that as a fraction. Okay. And now I want the probability of getting something less than 4. So we've still got 8 things. And, all of them are less than 4. Because we've only got 1s, 2s, and 3s. So if you called that 8/8, that's fine. If you called that 1, that's fine. If you called that 100%, that's fine. Any of those are fine. So all of those things are going to be less than 4. Okay. Moving along. That got smudged. Not bad. Okay, so these ones, and again, if you're following along on the review, you can see in the directions we've got a coin that we're spinning coin that we're flipping, not spinning. We're spinning the spinner and flipping the coin. Flipping, spinning. So we're flipping a coin and we're spinning the spinner that has red, white, and blue. And again, we're assuming that these are evenly spaced on our spinner, so these are exactly 1/3. And the first thing we want is our sample space. And big thing to remember about sample space is that's all of the things that can happen. So that's just a list of all the different things we could get if we flip this coin and spin this spinner. So I could get heads. And along with that heads, I could get red. I could also get heads and white. I could also get heads and blue. Very patriotic spinner, red, white, and blue. And I could also get the same thing with tails. I could get tails in red. I could get tails in white. I could get tails in blue. And one good way to make sure that you got all of your things for your sample space is to go, hey, we got 2 things here, we've got 3 things here, so if we got 2 things and 3 things, we should end up with 2 times 3 or 6 things. And sure enough, 1, 2, 3, 4, 5, 6, yes we did. So we got our whole sample space and we're good. Okay. Now, once we've got our sample space, we want the probability that we get heads and blue. And remember, in order for that and thing to be true, we want both of those things to be true. So the only one of those where both of those are true is this one here where we've got heads and blue. So that's 1 out of our 6 things. And again, I would just leave that as a fraction. If you really, really, really want a decimal, go for it. Okay, and now I want tails and a primary color, and I'm pretty sure I jotted down on the sheet that primary colors, if you don't remember from like elementary school colors, are red and blue and yellow. I don't want that being the reason you get this wrong, so those are primary colors. Okay. So we want tails and a primary color. So again, we're looking up at this stuff and we want the ones that are tails and a primary color. So tails and red counts, tails and blue counts, but not tails and white because that's not a primary color, and not any of these because we need it to be tails and that thing. So we've got 2 out of 6, which reduces to 1/3. And again, if you really want a decimal or a percent, go for it. I would just leave it like that. All right. And hopefully we're good on spinners and coins. All right. Now we're getting into the longer word problem is things where I didn't write out the whole thing. So this one, we've got a sandwich, and we can have either white, wheat, or rye bread. We can have either chicken, ham, turkey, or beef, and we can have Swiss, American, Parmesan, mozzarella, I can read my writing there, and cheddar. So think back to when we were doing the fundamental counting principle. If I just want to know how many things I want, so I'm not looking for the sample space here. We don't want to list off every single one of these things. That would take a while. The only thing we're looking for is how many different combinations we can have. And remember, if we want that, we're just multiplying. So we're multiplying how many of these things we have, which is 3, times how many of these things we have, which is 4, times how many of these things we have, which is 5. 1, 2, 3, 4, 5. And 3 times 4 times 5 gives you 60. I'm going to assume you said 60. Oh, and yeah, feel free to also use your calculator on the test. There is no non-calculator part of this. Alright, since I obviously don't have a way to stop you from using those either. If you don't have a calculator with you, feel free to pull up one on your computer and use that. That's fine. There shouldn't be anything that you need to do with it on there that a calculator on your computer wouldn't have. I mean, we're really just multiplying there. Okay. And again, we're just looking for how many of those things there are. We don't want to list off every single one. Please don't do that. Now, I mean, technically, if you wanted to find the 60 that way by going through and finding every single combination, you could. So if you're stuck and you don't happen to remember that you can just multiply it, that's one thing you could do. It would just take a while, and you want to make sure you get all of them. Okay. Now, we've got 6 shirts, 3 pairs of pants, 7 pairs of socks, and we want to know how many different outfits we can make. And we're assuming here that we're not doing something like mixing and matching the socks. So we got pairs of socks that go together, and we're not mixing those up. Okay, so as long as we're assuming that, we're just multiplying. So we got 6 shirts, 3 pairs of pants, and 7 pairs of socks, and 6 times 3 times 7 is 126. Yeah, please do not go through and list out all of those possibilities. That would be long. Don't do that. Okay, and there we go. Alright, so now, this time we've got, again, I didn't write out the whole thing, I just drew a little picture to go with it. So we got Bruce and Clark and Tony and Steve, and they're standing in a line, and we want to know how many different orders they could stand in. And again, instead of going through and finding every single combination, we can just go, okay, well, I've got 4 spots in line. I'm actually going to make that a little bit shorter so that we don't run out of room here, because we're going to have an equal sign there. So we've got 4 different spots, and if I've got 4 people, I've got 1, 2, 3, 4 people who could stand first in line. Now, once we've got that person in place, if there's somebody here, I've only got 3 people left to go here. And once we've got those 2 people, we've only got 2 people left who could go here. And once we've got those 3 people in place, there's only 1 person left to go here. So whoever's left goes there. So, I mean, we're assuming that we can't have multiple of Tony or Clark or Steve. None of them have those superpowers. Okay. So we've got 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. And again, feel free to use your calculator for that. And technically, you could leave off that times 1. It's not going to do anything. It's not going to hurt anything if it's there. Alright, and now we've got 12 students. And we want to select a president, a vice president, and a secretary. And we're assuming here, again, that we can't have repeats. So the same person can't be the president and the vice president and the secretary. So those have to be 3 different people. Okay, so we got 3 different spots. Now watch out for this time, we're not starting with 3, because we've got 12 students altogether, so 12 of them could be the president. Once we've got a president, we've only got 11 people left who could be the vice president. And once we've got those 2, we've only got 10 people left who could be the secretary. So watch out for these ones. We're not starting with 3, we're starting with 12, because that's how many total people we have. So this first number is going to be your total number of people. Up here, it just happened to be the same thing as the number of people we had in our line, because we want to put all of our people in line. This time we don't want all of our people, we just want 3 spots. So we're just going 12 times 11 times 10, which gives you 1,320. Please do not go through to write out all 1,320 combinations. That would be long and messy. Don't do that. Okay. So again, we're just looking for how many combinations. We don't want to list out all of them. So the only thing where you're going to list out all of your possibilities is if it specifically says you're looking for your sample space. Otherwise, don't do that. That's long and annoying, and you don't want to do that. I don't want to grade that. Okay. Couple more. This time we got a bag of marbles. I think it was marbles. And we have 12 purple marbles, 3 red marbles, 10 blue marbles. I can't remember if I made up marbles or jelly beans on this one. Okay, so we've got 12 purple, 3 red, and 10 blue of whatever these are. And the important thing is we're not putting it back. So whatever these are, once we take them out, we're not putting them back. So if I want a purple and then a blue, I'm taking that purple out and I'm not putting it back before I pick the blue. Okay. So, if we're looking for a purple first, we've got 12 and 3 and 10 gives you 25. And out of those 25, 12 of them are purple. Once we've got that purple, and this is where that don't put it back thing is important, once we've got that purple, we've only got 24 marbles left. So we took out a purple one. That changes our total number of things. What it doesn't change is our number of blue marbles. So we've still got 10 blue marbles because we picked a purple one first. So we have a purple one here, blue one here. That doesn't change our number. The number of blue marbles does change our total. Alright, and then we've got 12 times 10 is 120. 25 times 24 is something. More specifically, it's 600. And again, not gonna get on you for not reducing these. If you left it like that, that's not the main point right now. If you went through and reduced that to 1/5, that's fine. If you happen to realize back here that 5 goes into both of these, and 12 goes into both of these, and then you can cancel out those 2's, and then you've got 1/5 right there, that's fine. I'm worried about, can you get here? We can worry about reducing fractions some other time. That's not the main point right now. As long as you can get here, we're good. Or if you took that and you took your top divided by bottom and you turned that into a decimal or a percent and called that 20%, that would also be fine. Any of those things, now is not the time to be picky about which one of those things you have. Okay, now I'm going to put that purple back because we're looking for 2 purple. So if we want 2 purple in a row, we've still got that 12 out of 25 for our first purple. And this time, that is going to change the number that's on the top, because we took out a purple. So now I've only got 11 purple left for our second one, out of, again, 24 marbles total. And 12 times 11 is 132. 25 times 24 is still 600. And again, if you happen to realize back here that 12 goes into both of those, you could save yourself a little bit of reducing later and go, hey, that's 11 over 50. Again, not the main point. If you got here, I'm happy. This is the main point. This is reducing fractions. We can worry about that later. Most of your calculators will do that for you, actually. Okay. So that is the Chapter 9 review. Hopefully that was pretty painless. Go ahead and email me once you're done watching this and taking notes, and I will give you a link to the test. Quick thing with the Google Docs, do not write in the Google Docs. Do not comment in the Google Docs. You shouldn't be able to anyway. I figured that out last time. I think I have it set up this time where you can't do that anyway, but if you figure out a way to do that, please don't. Alright, and I will see you in the next chapter.